So, have you finished? Have you finished this question?
Yes, sir.
Okay. Now, let us consider the solution. Here we are considering another type of problem from lines inclined to HP and VP. Here, what are the specialties of this problem? The position of end A and end B are given. The position of end A is 10 mm above HP and 20 mm in front of VP, and end B is located 45 mm above HP and 50 mm in front of VP. And the projectiles, the distance between the projectiles are also given. That means you can draw the line, the projection, the final, you can draw the final projection of line AB, because the position of end B, A and B are given. And what is the question? Here, in this question, we have to find the true length and true inclination of the line, and we have to mark the traces. Here, line AB is inclined to SP and VP. So, what is the specialty? Neither in plan nor in elevation you will get the true length of line AB or true inclination. Here we will get in the initial, here in after marking, after drawing the plan and elevation, you will get the apparent length and apparent inclinations of line AB. We have to find the true length and true inclination, and also you have to mark the places. Now let us start the problem. First, you draw the XY line and draw the first end projector after leaving some distance in the left hand side, and mark the position of A and A dash. Do it. Draw XY line, then draw the first end projector and mark the position of end A. It is 10 mm above SP and 20 mm in front of VP. Do it. What's your total strength class strength?
56.
56. So there are 7 absentees. They will be in trouble in the next class. Have you finished? Have you marked?
Yes, sir.
Okay. So after this, so you have marked, you have drawn the first end projector, and you have marked A and A dash. A is the plan and A dash is the elevation. This distance is 10 mm and this distance is 20 mm. Then what next? Here, the distance between the n projectiles are given is 30 mm. So here we have the first n projectile and we have marked A and A dash. And here this distance is given. So after leaving 30 mm, you draw the second n projectile here. Do it. This distance must be 30 mm. It is given in the question. Do it. And on that second n projectile, you can mark the position of end B. It is 45 mm above SP and 50 mm in front of B. So draw the second end projector after leaving 30 mm from the first end projector, and on that end projector mark the position of B dash and B. Projector lines must be thin lines. In my presentation, it is appearing to be too dark because it is a photograph. So it will appear to be darker. In your drawing, the projector lines must be thin lines. How to use H pencil? Have you marked B dash and B? Can I proceed?
Yes, sir.
Okay, so we obtained B dash and B. This distance is given and it is 45 mm. This distance is given and it is 50 mm. After obtaining these points, you can connect A dash and B dash and A and B by means of straight lines. You connect A dash and B dash and A and B. And this is the elevation and plan of line AB, which is inclined to SP and B. Have you connected A dash, B dash and A and B?
Yes, sir.
Okay, so here you can draw a horizontal projector line from A dash like this and another horizontal line from point A like this. And here you are marking the apparent inclination in the elevation is marked as alpha. So draw this horizontal line from A dash. It must be a thin line. Draw this line and mark this angle as alpha. And another horizontal line from point A and mark this angle as beta. Alpha is the apparent inclination in the elevation and beta is the apparent inclination in the plan. Have you marked alpha and beta?
Yes, sir.
Okay. So what is the specialties of this condition? Here, A dash B dash. A dash B dash is the apparent length of line AB in the elevation, which is known as the elevation length. And alpha, what is alpha? Alpha is the apparent inclination of line AB in the elevation. A dash B dash is the elevation length and alpha is the apparent inclination in the elevation. Now, consider the plan. Here we have line small AB. If you measure this length, you will get the apparent length of line AB in the plan, which is also known as the plan length of line AB. It is not the actual length, but it is the plan length of line AB. It is the apparent length in the plan. And what about this angle beta? Beta is the apparent inclination of line AB with respect to the vertical plane. What is the speciality of apparent inclination? Apparent inclination will always be greater than the actual inclination. Here alpha and beta will be greater than the actual inclination of line AB with respect to HP and VB. Alpha will be greater than theta and beta will be greater than phi. Now, what next? Here we have point B dash. Let us mark the locus plane of point B dash and B. So how do you mark that? For marking the locus plane, you have to draw a horizontal line, a thin horizontal line through point B dash, and you can mark it as locus of B dash. So this is the locus of B dash. Similarly, you will draw another horizontal line through point small b like this. And that is the locus of small b. You draw the locus lines. It must be thin lines. Have you drawn the locus planes?
Yes, sir.
Okay. Now, here we have to let us let us find the true length and true inclination of the line. Let us find the true length, true inclination of line AB with respect to HP. First, let us find the value of theta. So now the line is inclined to both reference. And as per your rule, if a line is parallel to VP, then in the elevation it should reveal its true length and true inclination in the elevation. And if the line is parallel to HP, then in the plan it should reveal its true length and true inclination in the plan. So in my drawing, I am finding the true length and true inclination in the plan. So I am proceeding like that. So first we will be finding the true inclination of the line with respect to VP. So I am changing my track. So first I am finding the true inclination of line with respect to VP. That means I am going to find the value of 5 at first. So how can you find the true length and true inclination of a line with respect to VP? For that, the line AB must be parallel to SP. If line AB is parallel to SP, then in the plan it will reveal its true length and true inclination. That is our rule. So how can you achieve that? So I am moving to the next slide. So here we have line A dash B dash. You take your compass and take radius A dash B dash. And with A dash as center, draw an arc like this and intersect this horizontal line at point B1 dash. Do it. You are making line A dash B dash parallel to SP by drawing this arc. Do it. Take this radius, that is A dash B dash, and with A dash as center, drawing an arc from B dash and intersecting this horizontal line, this thin horizontal line at point B1 dash. We are making A dash B dash parallel to SP so that you will get B1 dash. Do it. Finish?
Yes, sir.
So now we have a line A dash B1 dash. So what is the specialty of A dash B1 dash line A dash B1 dash? It is parallel to SP. We have tilted this line so that B dash is parallel to SP. So if you are tilting like this, what will happen to end B in the plan? Here we have line AB, and in the elevation we are tilting like this. What will happen to point B? Point B will move along the locus plane. This is our locus plane. If you are tilting like this, what will happen to point B? Point B will move along the locus plane. Now, how will you locate the exact position? For that, you are drawing a vertical projector from B1 dash and intersecting this locus plane. And here we will get the intersection and we can name it as B1. You mark the position of B1. Draw a vertical projector from B1 dash. It will intersect the locus of B line at a point, and that is B1. If you are making line A dash B dash parallel to SP, then what will happen in the plan? End B will move along the locus plane. This is our locus plane, and ultimately it is reaching here. And by drawing a vertical projector, you can locate the exact location of B1. So this is B1. You can join AB1 line. Do it. Have you completed this?
Yes, sir.
Here, what is the specialty of line A dash B1 dash or line AB1. It is a line which is parallel to SP and inclined to VP. What is the specialty of lines inclined to parallel to SP and inclined to VP? If a line is parallel to SP and inclined to VP, then in the plan it should reveal its true length and true inclination. That means AB1, if you measure AB1, then you will get the true length of line AB. And if you measure this angle, then you will get the actual inclination of line AB with respect to VP. So this is 5. And if you measure AB1, then you will get the true length of line AB. Ahmad Naim. Ahmad Naim. Ahmad Naim. Are you there? Ahmad Naim. Ahmad Naim. He is not responding. He is absent. He is absent. I'll put absent for that person. Then Ashwini Kumar. Ashwini S. Kumar. Ashwini S. Kumar. Ashwini S. Kumar. Absent. Ashwini S. Kumar absent. Gautam Krishna. Gautam Krishna. Okay. What is the value of 5? What is the value of 5?
Sir, I haven't got, sir. I am still drawing, sir.
What is the value?
Sir, I am still drawing.
Still drawing.
Yes, sir.
What happened?
Sir, I just went.
No. You are. I think you are lazy. There was enough time.
No, sir.
There was enough time. Okay. Kajal. Kajal.
Yes, sir.
What is the value of 5?
35 degree.
35 degree. Noel Baby. Noel Baby.
Yes, sir.
What is the value of 5?
34.
Okay. Sri Shankar.
Yes, sir.
What is the value of 5?
55.
Okay, it is around 35 degree. Muhammad Rasi. Muhammad Rasi.
Yes, sir.
What is the true length? What is the length of line AB1? That is the true length. What is the length?
5.5.
5.5. I need dimension in mm, not in centimeters. All dimensions must be in mm. So what is the value?
55 millimeters, sir.
55. Yes. Best King's career. What is the true length?
55 mm.
Amala Varghese. Amala Varghese.
Yes, sir.
What is the true length?
55 mm.
55 mm. Abhinav SS. Abhinav SS. Is it correct? Abhinav. Okay. Some problem is there. No problem. It's okay. It's okay. So, the true length of line AB is 55 mm, and what's the value? Phi is around 35 degree. So that is the value of true length and phi. What is phi? Phi is the actual inclination of line AB with respect to VP. Now, what next? We have to find the true length of line, the true inclination of line AB with respect to HP. So, how will you find that? You can repeat the process in the opposite sequence. So, how will you do that? You will make line AB parallel to XY line, and in the elevation you will get the true length and true inclination. That means if the line is parallel to VP, then in the elevation it should reveal its true length and true inclination. I am moving to the next slide. So that is done here. So in this, you take your compass and take radius AB. Here A is missing, you have to put that. So take radius AB, small AB in your compass, and draw an arc and intersect this horizontal line at point B2. You will get this intersection here. You can name that point as B2. Making line AB parallel to VP. So, if you are making line AB parallel to VP, what will happen to point B dash? B dash will move along the locus plane. If you are making it parallel to VP, what will happen to B dash? It will move along the locus plane. Here we have the locus of B dash. It will move along this plane. So after marking B2, you can locate B2 dash by drawing a vertical projector like this. So from point B2, you draw a vertical projector and we will intersect this locus plane. And that intersection is B2 dash. So obtain B2 and B2 dash. Have you obtained B2 and B2 dash?
Yes, sir.
Okay. So here, what is the speciality of AB2? AB2 is parallel to VP and inclined to SP. So after marking B2 dash, we can connect A dash B2 dash by means of a straight line. So what is the speciality of line AB2? AB2 is parallel to VP and inclined to SP. What is the general characteristic of lines parallel to VP and inclined to SP? If a line is parallel to VP and inclined to SP, then in the elevation, it will reveal its true length and true inclination with respect to SP. That means A dash B2 dash will give the true length, and this inclination is our true length of line AB with respect to SP. That means this is our theta. So you measure the angle and measure A dash B2 dash. It must be the length of A dash B2 dash and length of AB1 must be the same. Finish?
Yes, sir.
Abhishek H. Abhishek H.
Hello?
Have you finished the problem? Have you finished the problem?
No, sir. ചെയ്യുക. മതി.
Arun Das.
Yes, sir.
Have you finished the problem?
Yes.
What is the
Yes, sir.
value? What is the value of
55.
this?
55 mm.
52,
55
55.
mm.
What is the value of theta? Angle.
Angle 42.
Copy?
2.
42. Catherine. Catherine.
Yes, sir.
What is the value of theta?
44.
44.
40.
40 degree.
Yes, sir.
Lakshmi.
Yes, sir.
What is the value of theta?
40 degree.
40 degree. Saurav.
Yes, sir.
What is the length you obtain? That is length of A dash, B2 dash.
55 mm.
55. Susan Varghese.
Yes, sir.
Have you got these values?
Yes, sir.
Okay. So we have obtained the true inclination and the true length of line AB. Phi is 35, theta is 40, and the true length is obtained as 55 mm. We obtained the true length from here and from here. It must tally. That means A dash B2 dash and AB1 must be the same. If they are different, then there must be a mistake. 1 or 2 mm can be tolerated, but above that, it is a mistake. It must tally. So we obtain the first part of our problem. Now, what next? We have to mark the traces. So that is done here. Here the line is inclined to HP and VP. So there will be horizontal trace and vertical trace. First, let us think about the horizontal trace. So what are the steps for marking the horizontal trace? For marking the horizontal trace, first you extend the elevation. Here, what is the elevation? That is A dash B dash. It is not A dash B2 dash. That is a common mistake. The elevation is A dash B dash. Extend the actual elevation line. A dash B dash. Extend A dash B dash to intersect the XY line. And you can mark that intersection as point small h. In my drawing, it is marked as small h. You mark that point as small h. Otherwise, may be confused as the horizontal trace. So better mark that point as small h. So extend line A dash B dash and intersect line XY here and mark it as point small h. So here we will get this point. Then what next? From that intersection point, erect a perpendicular. Here you are drawing a vertical projector through point small h, so that you will get this line. So you please mute your. Who is that? Mute your audio. Okay. So erect this perpendicular. Then what next? After that, after erecting the perpendicular, you consider the line representing the plan. Here the line representing the plan is AB. This line AB. Extend that line like this, and it will intersect this vertical projector line from point H, and that intersection is our horizontal trace. We mark this point and label it as capital HT. That is our horizontal trace. So what is horizontal trace? Horizontal trace is the point of penetration of a line with respect to the horizontal plane. Here line AB will penetrate through the horizontal plane at this point. That is our horizontal trace. Have you marked the horizontal trace?
Yes, sir.
Yes, sir.
Anakha, Mohan. Anakha, have you marked the horizontal trace?
Yes, sir.
Okay. Now, what next? We have to obtain the position of vertical trace. So, for that, what are the steps? You consider the plan. Here, the plan is line AB. This line is not AB1, but it is AB, the actual plan line. Extend the line representing the plan. Here it is AB to meet the XY line. So extend line AB and intersect the XY line. The intersection can be named as small v. Yes, in my drawing it is small vt. You better avoid this t here. Otherwise it may be confused. So this intersection is named as small v. Then, after obtaining small v, what is the next step? Erect a perpendicular. Erect a vertical projector line through point small v. Like this, you can obtain this line. Then, what next? Here we have line A dash B dash. This is our elevation line. You extend the elevation line, that is A dash B dash, like this, and intersect this vertical projector line drawn from point small v, and this intersection is our vertical trace VP. So what are the steps? Extend line AB, that is the plan, to meet the XY line and mark it as small v. Through point small v, you are drawing a vertical projector line like this. After that, you extend the elevation, that is A dash B dash, like this, and intersect the vertical projector line, and that point is our actual vertical trace VP. So what is vertical trace? Vertical trace is the point of penetration of a line with respect to the vertical plane. Here, line AB will penetrate through the vertical plane at this position. It will penetrate through the horizontal plane at this position. So you mark ST and VP. Do it. Have you completed this?
Yes, sir.
Okay. I will demonstrate that. Just a minute. I'm sharing my 3D window. Can you see the 3D window?
Yes, sir.
So here the line is inclined to SP and VP. So here you can see that the line is penetrating the horizontal plane at this location, and it is penetrating the vertical plane at this location. This is the horizontal trace, and this is the vertical trace. So that is the explanation of this horizontal trace and vertical trace. Can you see this?
Yes, sir.
Yes, sir.
This is the horizontal trace, and this is the vertical trace. Now I am returning to the PowerPoint. So we have finished the problem. Our final step is marking the dimensions. So what are the dimensions that you have to mark? The dimensions that are given in the question must be marked here. The position of end A, that must be marked here. This dimension is 10 mm, this dimension is 20 mm. That must be marked here. Then the position of B dash and B are given. This length is given. You have to mark that. This dimension, that is also given in the question. You have to mark that. Then one dimension, that is the distance between the n projectiles. The distance between these two projectiles are given, it is 30 mm. That must be marked here at the bottom part of your drawing. And you can consider it as a homework. You have to dimension this drawing. Then what next? You have to write the value of theta, phi, and the true length. Here in this drawing, you have to mark the distance A dash, B dash, B2 dash as the true length. So you have to draw an inclined dimension line and you can mark it as TL. Here also AB1 represents the true length. So here you have to write it is TL. And these values must be marked in a rectangular box at the top right corner. Theta is equal to, say, what is the value? It's 40 degree, I think. Then phi is 35 degree. TL is 55 mm. These values must be shown at the top right corner in a rectangle. And you have to do that. And I am proceeding to the next problem. Any doubt in this question? If you have any doubt, then you can.
Sir, mate horizontal trace vertical trace ഒന്നുകൂടി ഒന്ന് പറയാമോ?
ഏത് മനസ്സിലായില്ല?
ഹൊറിസോണ്ടൽ ട്രേസും വെർട്ടിക്കൽ ട്രേസും ഇല്ലേ, ഈ ഒരു കേസിൽ ഒന്നുകൂടി പറയാമോ?
ഓ, അത് വരയ്ക്കുന്ന മെത്തേഡ് ആണോ?
മെത്തേഡ് അല്ല, അത്
അതിന്റെ കൺസെപ്റ്റ് 3D വിൻഡോ കാണിക്കണം അല്ലേ?
യെസ്.
കാണിക്കാം. ജസ്റ്റ് can you see this?
Yes, sir.
Okay. So first of all, let us consider a line which is parallel to HP and so now the line is parallel to HP and VP. So what is the specialty of this line? This line will not intersect HP or VP. That means there won't be any horizontal trace or vertical trace. Now consider that the line is inclined to SP. If the line is inclined to SP, then you see this. Here the line is parallel to VP but inclined to SP. In this particular case, the line will penetrate through the horizontal trace at a particular, if you extend that line, the line has a finite length, but if you extend that line, then it will penetrate through the horizontal plane at a point. That point of penetration is our horizontal trace. Now, consider that the line is parallel to SP and inclined to VP. In this particular case, here the line is parallel to HP. That means there won't be any horizontal trace because it will not penetrate the horizontal plane. That means there won't be horizontal trace. But the line is inclined to VP. That means it will, if you extend that line, then at a particular position, particular point, it will penetrate through the vertical plane. So in this particular case, there won't be any horizontal trace, but there will be a vertical trace. Here, the line is penetrating the vertical plane at this point, and this is our vertical trace. Now, suppose that the line is inclined to HP and VP. Now, I am tilting it with respect to HP. So, in this condition, here the line is penetrating the vertical plane, and if you extend that line, I'm extending that line. little bit. If you extend that line, then you see this. It will penetrate through the vertical plane, and it is penetrating through the horizontal plane. Here, in this particular case, the vertical trace is above SP and horizontal trace is behind VP. You see this. Here it is penetrating the vertical plane. Here it is penetrating the horizontal plane. This is the vertical trace. This is the horizontal trace. Now, if you move this line like this, you see this. In this particular condition, the line will penetrate the horizontal plane at this location, and it will penetrate through the vertical plane at this location. You see this. Now, what is the specialty of these traces? Here, the horizontal trace is in front of VP. And what is the specialty of vertical trace? It is below SP. You see this? Below SP. And here the horizontal trace is in front of VP. You see this? That is depending upon the position of these points. Depending upon the position of the points, its horizontal trace and vertical trace will change. Is it clear now?
Yes, sir.
Okay. So I am returning to my PowerPoint window. Any doubt? Any other doubt?
No, sir.
So I am proceeding to the next program. To take down this program, can you see this slide?
Yes,
Yes,
sir.
sir.
Okay, take down this program. A line AB of 90 mm length is inclined to SP by 30 degrees. Its NDA is 10 mm above SP and 20 mm in front of VP. Its front view measures 65 mm. Draw the projection of line AB and find its true inclination with respect to VP. It's another type of problem. And in this points and lines, there can be several combinations. You can solve the problems by applying our rules. We already discussed some rule, first rule, second rule, etc. By applying that rules, you can solve every problem in points and lines. If you are thorough with these rules, you can solve any problem from this topic. Have you finished the question?
Yes, sir.
So here, the true length of line AB is given. It is 90 mm. It is inclined to SP by 30 degrees. That means theta is given. The true inclination of line AB with respect to SP is given, and Then in the next sentence, NDA is 10 mm above SP and 20 mm in front. That means the position of NDA is given. Then what next? The front view measures 65 mm. Front view measures. That means here the line is inclined to SP and VP. In the question, it is not clear, but it is inclined to SP and VP. So here, the third sentence, its front view measures 65. That means the elevation length of line AB is given, that is 65 mm. In the elevation, line or A dash B dash is making the length of line A dash B dash is 65 mm. That is the given parameter. You have to draw the projection and you have to find the true inclination of line AB with respect to VP. So let us solve this problem. First, you draw the XY line and draw the first N projector, and you can mark the position of A dash and E. Do it. Draw the XY line. Draw the first N projector. Mark A dash and E. Have you completed that?
Yes, sir.
Point A dash and A. Okay. After that, so for the time being, let us assume that the line is parallel to SP and VP. So what is the specialty of a line parallel to SP and VP? In the plan and elevation, it will reveal its true length. So let us assume that it is parallel. So in that particular condition, you can locate B1 here. This distance will be equal to the true length of line AB, which is given, and it is 90 mm. So after leaving 90 mm from the first N projector, you can draw the second N projector here. This distance must be 90 mm. Then from point A dash, you can draw a horizontal line, intersect the second N projector here, and that is B1. Similarly, from point A, you draw another horizontal line and intersect the second N projector at point B1. And so here, this is B1 dash. This is B1 dash. This is point B1. This dash symbol is missing here. How to put this dash symbol? This line is A dash B1 dash. This is AB1. We are assuming the line is parallel to SP and V. Have you completed this?
Yes, sir.
Okay. Now, the true inclination of line with respect to SP is given. So, now let us proceed to the next stage, in which the line is inclined to SP and parallel to V. So let us tilt the line A dash B1 dash with respect to the XY line by 30 degrees because it is given in the question. Theta is given in the question. So let us draw that. So from point A dash, you draw a 30-degree line like this. Draw a 30-degree line like this. And after that, you take your compass and take radius A dash, B1 dash. This is B1 dash. Take radius A dash, B1 dash. And draw an arc and intersect this 30-degree line. And the intersection can be marked as B2 dash. Draw a 30-degree line from A dash. Must be of sufficient length. Now we don't know the position of B2 dash. For obtaining B2 dash, you have to take this radius, that is A dash B1 dash, this is B1 dash, and draw an arc and intersect. And this is B2 dash. Have you obtained B2 dash?
Yes, sir.
Yes, sir.
Okay. Now, what next? We have to mark the corresponding position in the plan. So, how do you mark that? Draw a vertical projector line like this. From B2 dash, you can draw a vertical projector line that will intersect AB1 at a point. You can mark that point as B2. So this is the condition where the line is parallel to VP and inclined to ST. Here, this is our value of theta. A dash, B2 dash will give the true length, but AB2 will give only the apparent inclination in the plan, which is also known as the plan length. So AB2 is the plan length of line AB. Now we obtain the plan length of line AB. This length is the plan length. Arun Syriac. Arun Syriac.
Sir.
Have you obtained a AB2?
Yes, sir.
What is the length? What is the plan length?
Sir, sir, 88 millimeter.
88 mm. 88 mm. No.
Sir, A dash, B2 dash.
A dash, B2 dash. No, not A dash, B2 dash. A, B2. The plan length. is
76 mm.
Arya C. Arya.
Sir. Yes, sir.
What is the length?
79 mm.
79 mm. Okay. Gauri.
Yes, sir.
What is
74 millimeter.
70?
4.
74. Jyotika.
Yes, sir.
Jyotika.
Yes, sir. Sir?
Plan length. What is the plan length?
Sir, I got it as 76 millimeter.
Okay. Safna,
Yes, sir.
what is the plan length?
79 millimeter.
79. Jewel.
77.
77. Okay, this is around 78 mm. So we obtained the plan length. Now, what next? Here, the line is parallel to VP and inclined to S. So here we have B2 dash. Let us mark the locus line, the locus of B dash, by drawing a horizontal line. Here, draw a thin line, thin horizontal line through point B2 dash and label it as locus of B dash. Draw this line. Have you drawn that? Have you drawn that?
Yes, sir.
Okay. Now, what next? The elevation length of line AB is given. What is the elevation length, Namita? What is the
Yes, sir.
what is the elevation length given? Elevation length
65 millimeter.
65. Yes, it is given in the question. So, how can you mark that here? We know the locus plane. This is point. This is the locus of B dash, and we know that the elevation length is 65. So, what you have to do? Take 65 mm in your compass and with the A dash as center, intersect on this locus line so that you will get the position of B dash here. So, take radius 65 mm because we know that the apparent length in the elevation is 65 mm. Take that radius with the A dash as center, intersect on the locus plane and label it as B dash. Have you obtained B dash? Have you obtained B dash?
Yes, sir.
Okay. So, we obtained the elevation of line AB. Now, it's not finished. We have to locate the position of B. But for the time being, we can't locate that. So, how will you locate that? So, I am proceeding to the next slide. So, here we have line A dash B dash. A dash B dash is the condition where the line is inclined to ST and VP. A dash B dash is the elevation obtained when the line is inclined to SP and VP. A dash B2 dash is the condition where the line is parallel to VP and inclined to SP. But A dash B dash is the condition where it is making inclination with both reference plane. So, now the line is inclined to SP and V. We have to, from point here we have point A dash B dash. From this, we have to obtain the position of point B. So, for that, let us make this line A dash B dash parallel to SP. So if a line is parallel to SP, then we know that in the plan it should reveal its true length and true inclination. So by applying that rule, let us make this line parallel to SP. So for that, take your compass and with take radius A dash B dash, that is 65 mm, and draw an arc and intersect this horizontal line at this point and label it as B3 dash. Here it is not B3, it is B3 dash. Draw this arc and mark this intersection as B3 dash. Have you obtained B3 dash?
Yes, sir.
Okay. So now line AB3 is parallel to SP. If a line is parallel to SP, then in the plan it should reveal its true length and true inclination. So from point B3, you draw a vertical projector line like this. This is B3 dash. From point B3 dash, you are drawing a vertical projector line. And we know that point B3 will be on this side. Here line A dash B3 dash is parallel to SP and inclined to EP. Here actually it was inclined to both reference frame. We are making it parallel to one of the reference frame by drawing this up. Now AB3, this is the condition where the line AB is parallel to SP and inclined to VP. In that situation, in the plan, it should reveal its true length. So, you draw this vertical projector, then you take AB1 in your compass. This AB1 is the true length of line AB. If a line is parallel to SP, then in the plan it should reveal its true length. So you take the true length in your compass. That is, what is the value? This is 90 mm, isn't it? What is the true length? Hanna, what is the true length given? Hanna.
Yes,
What is the true length?
90 millimeter.
90 mm. So take 90 mm in your compass. Here A dash B3 dash is parallel to SP. So in the plan it should show that 90 mm. So take that radius in your compass and intersect here so that you will get the position of B3. So this is the true length and this angle is the true inclination of line AB with respect to BP. This is phi. What is the value of phi? Have you completed this?
Yes, sir.
Faha Fatima. Faha Fatima. Faha. What is the value of phi?
Hello, sir.
What is the value of phi?
45.
75.
45.
45. Besting.
Sir.
Besting. What is the value 5?
43.
Anthony Paul.
Yes, sir.
What is the value 5?
44.
Okay. So it is around 45 degree. So we obtain the true inclination of line AB with respect to V. So this is the problem is not finished because we have to locate the position of point B also. We have to complete the projection. So we obtained B3. This is the condition where the line is parallel to SP and inclined to BP. We have to obtain the position of point B. How do you obtain that? For that, through point B3, you draw a horizontal line, and that is our locus of B. Draw the locus line like this. Through point B3, you are drawing a horizontal line, which is the locus line. If you are tilting the line with respect to SP, then end B will move along this plane. So draw the locus line. Then what next? From point B dash, you are erecting a vertical projector and intersecting the locus plane here. So through point B3, you are drawing the locus plane, then erecting a perpendicular from B dash and intersecting it here. And you can name it as point small b. This is small a, this is small b. You can connect by means of a straight line, and that is the plan of line AB. Have you obtained AB? Direct a perpendicular from B dash. Intersect the locus plane here. Then connect AB. Finish? There's no answer. Have you finished the problem?
Yes, sir.
Okay. Then you have to verify the answer. For that, we take this radius, that is AB. Take radius AB and draw an arc and intersect it here. If it is passing through point B2, then it is, the answer is correct. Here we obtained B2 here, and from point B you are drawing an arc in this direction. If it is passing through point B2, then your solution is correct. Is it intersecting?
Yes, sir.
Okay, that is a confirmation. And that is the solution of this problem. Any doubt in this is slightly complex. You have to apply the basic concepts for solving this problem. Any doubt here?
No, sir.
Okay, let us proceed to the next program. Take down this question. Line AB of 100 mm length is inclined PHP by 30 degree. NDA is 15 mm below ST and 20 mm behind V. The front view of the line measures 75 mm. Draw the projection and find the inclination with VP. Have you finished the question? Have you finished the question?
Yes, sir.
Okay, here we have a special condition. Mr. Adul Krishna. Adul Krishna.
Yes, sir.
Here, the position of NDA is given. NDA is located in which quadrant?
And is located in
Which quadrant?
second quadrant.
Second quadrant. Is it correct?
Third quadrant, no.
Next person. Muhammad Rasi. Muhammad Rasi. Muhammad Rasi.
Sir.
Point A is located in which quadrant?
Third quadrant.
Third quadrant അല്ലേ നോ?
Third quadrant.
ഞാനല്ലേ ചോദിച്ചത്. ഇയാൾ ഇങ്ങോട്ട് ചോദിച്ചാൽ എങ്ങനെ ശരിയാവുന്നത്?
Third quadrant, sir.
Anashwara. Anashwara.
Yes, sir.
NDA is located in which quadrant?
Third quadrant.
Which quadrant?
Third quadrant.
Third quadrant. Ashwin Rajan. Ashwin Rajan.
Yes, sir.
ഏത് ക്വാഡ്രന്റിലാണ് നമ്മൾ ലൊക്കേറ്റ് ചെയ്തിരിക്കുന്നത്?
Third quadrant.
Third. Okay. Here, NDA is located in the third quadrant. What is the specialty of points located in the third quadrant? Its elevation will be below XY line and plan will be above XY line. First, let us draw the XY line and let us assume that the line is parallel to HP and VP. So, draw the XY line, draw the first end projector, mark point A dash and A. Here A dash will be below XY line, A will be above XY line, plan will be above XY line and elevation will be below XY line. Mark point A and A dash. Finish? So proceeding. So after marking point A, how to assume that the line is parallel to HP and VP. Here the true length of the line is given. True inclination of line with respect to HP is given, that is theta is given. So initially we will assume that the line is parallel to HP and VP. So after leaving 100 mm from the first end projector, you can draw the second end projector somewhere around here. Then from point A dash you draw a horizontal line to obtain B1 dash. Another horizontal line through point B, intersect the second end projector, and that is point B1. Do it. Finish? So you can mark your attendance by sending a chat message. Mark your attendance by sending a chat message. So after this, so you have obtained this initial position. Have you obtained this? Can I proceed?
Yes, sir.
Now we will tilt the line with respect to HP. Here the true inclination of line with respect to HP is given, it is 30 degrees. So we can tilt the line with respect to HP by that inclination, keeping it parallel to VP. So in the next slide, I will be tilting the line with respect to HP. So here, see this. I am drawing a 30-degree line in this direction. Why I am drawing the 30-degree line in the opposite direction? Why I am taking this direction for drawing the 30-degree line? Lakshmi.
Yes, sir.
Why the 30-degree line is taken in this direction? Can you draw the 30-degree line in the opposite direction, say from here to somewhere around here? What is the reason for that?
Parallel to VP.
No.
Third quadrant line.
That is the reason. So here, A dash is located below HP. So if you are tilting in the opposite direction, what will happen to point B? Point B will be above HP. That means A is in one quadrant and B will be in another quadrant. We have to avoid that situation. So for that, we have to tilt the line in this direction so that it will not cross. So take 30 degree in this direction. Draw a 30-degree line from A dash in this direction and draw this arc. This radius is the true length, that is 100 mm. take 100 mm in your compass and with A dash as center, intersect this 30-degree line and obtain B2 dash. Do it. Draw a 30-degree line, then take 100 mm in your compass and with the A dash as center, draw an arc and intersect the 30-degree line at point B2 dash. After this, project upwards and obtain the position of B2 in the plan. Have you obtained B2 dash and B2?
Yes, sir.
Okay then. Then what next? Here also the plan length, the elevation length is given, isn't it? So through point B2 dash, you can draw a locus line. This is the locus line. Draw a locus line through point B2 dash. Here, the elevation length of the line is given. What is the elevation length given? What is the elevation length given? The front view of the line measures 75 mm, isn't it? So, through point B2 dash, draw a horizontal line, which is the locus plane. Then take 75 mm in your compass. That is the elevation length. Take elevation length in your compass and with the A dash as center, intersect on the locus plane. This radius is 75 mm, which is the elevation length. So that you will get B dash. Connect A dash, B dash, which is the elevation of line AB when it is inclined to both reference plane. Have you obtained B dash? Hurry up, I have to finish within 4 minutes. Have you obtained B dash?
Yes, sir.
Yes, sir.
Okay, then what next? You can draw a vertical projector from point B dash like this. Our point B will be on this line. Will be on this line. So draw this vertical projector. I'm moving to the next slide. Then what next? You consider the solution of the previous example. Here we have like the vertical projector and here we have A dash, B dash. This is the condition where the line is inclined to SP and V. You take this radius and draw an arc and intersect this horizontal line. We are making it parallel to SP. If the line is parallel to SP, then in the plan it should reveal its true length and true inclination. So we are making line A B parallel to SP. Take this radius, draw an arc and intersect this horizontal line so that you will get B3 dash. Now A dash B3 dash is parallel to HP. So in the elevation, in the plan, it should reveal its true length. You obtain B3 dash by drawing this arc. After that, draw a vertical projector like this. Have you obtained B3 dash? Have you obtained B3 dash?
Yes, sir.
Okay, after that you are drawing a vertical projector like this. And on this vertical projector, you take the actual length of line AB, that is 100 mm. Take 100 mm in your compass and intersect here so that you will get B3. This length is the true length. So take the actual length and intersect here, and that is B3. Then after that, you can draw this locus plane, and from B3 dash you have already drawn a vertical projector. This locus plane will intersect here, and that is point small b. You connect AB, and that is our final plan. And that is the solution. And I am concluding here. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.